Hi everybody, welcome to the video. So I'm going to show you guys how to convert a 3D file in STL format to G-code. So you're going to generate G-code for your 3D printer to understand how to put the layers down from the beginning to the end. So the first thing you want to do is open up your browser. Where's my browser here? And you want to go into Google. Okay. And you're going to want to type in Thingiverse, like I have it here. And once you click on the link for Thingiverse, you'll come up to the home page. Look, you don't have to create an account. Thingiverse is free to use as long as you agree to the terms of use and not abusing or reselling these items. I think you should be in the green. So yeah, Thingiverse is a large repository full of 3D models that makers, well, like myself, we design and we put fun, cool things on here, right, in 3D format, and you can obviously download the files and then 3D print them. So there's an array of different types and different categories and whatnot, and you can search through here like whatever you want in terms of what you want to find. And I mean, there's categories on what type of things you actually want to make. You got hand tools, machine tools, chess, dice, models. I mean, you know, the list is endless. You get art, 2D art, gadgets. Okay, so for our video today, or for the purpose of demonstration, we're going to look at the first thing we're going to look at. We're going to look at a phone stand. So yeah, I mean, this is just a simple little phone stand. Holds your phone. I've made a few of these already. I'd say maybe about 20. Yeah, so you basically it's just a simple shape that you can actually go in and make. Okay, so one thing to note before actually going in and downloading the files is actually to give this part here a read. So if you look at this summary, tells you the designer of the part actually tells you the recommended settings to print them. So the printer that he used here was this BCN 3D Sigma, and there's something called RAFs that I'll show you guys soon about RAF supports, and then the resolution and the info. So just remember these words or these terms. We're going to come back to it in a bit. Okay, so here what you want to do is you just want to click download, and it should automatically download. Okay, comes up with ads, downloads to wherever you need it to be on your computer. Okay, and then obviously you this is a zip file. You want to open that zip file, and you want to extract it somewhere on your computer. So if you look inside files, so all of the downloads from Cura, I mean from Thingiverse, come like this. So you'll have these files. You just want to get into files, and then you see that you're going to have a STL here. Now I've already got Cura installed on my computer, so it's going to come up with a Cura icon as it recognizes STL files for this software. So what you want to do is you want to just remember where this is saved, and then you want to come down to Cura. Okay, I'm not going to show you guys in this video how to install Cura, but it's pretty straightforward. Yeah, so just wait for that to boot up, and just remember where you saved the STL file. Okay, so this is what my current version of Cura looks like. You've got this, okay, let's start from the top here. So obviously you've got a string of things you can do: open, toggle full screen, preferences, help. You're not really going to touch any of these things. The main thing you want to touch is you want to come in here and you want to set your printer. So depending on the printer that you have, I've got CR20s and I've got Ender 3 Maxes. So you want to come in here and add your printer. So you're obviously not going to have a network printer, you're going to have a non-network printer, and then there's a big long list here on your printer and the size. So let's see, MakerBot. You can put in a replicator here, and then it would just pick up the bed settings and the build volume of your printer. So yeah, so in my example, I've got 2 Creality machines. So you'd come here to Creality 3D, and I mean, it's a simple thing as click, and it's quite straightforward. Okay, so you'd do that, you'd add it in, and then obviously it would configure this build volume depending on the size of your machine. So obviously here you got your right click is obviously going to move it around, and then obviously to zoom in and out, you use your mouse. Okay, so those what we're going to do now is also here you can change your nozzle. You can change your nozzle size and the material that you're using. They've even got stored settings on some of these popular materials, like from eSun. I personally use eSun PLA Plus, and yeah, so it puts it in there, and also your nozzle side. So now if you don't know too much about 3D printing, you're going to come in here on standard. Okay, it should say standard. And then you've got your settings on the side here. So in this ribbon, you've got all of your settings. So let's put in a model, and then we can see how it works. All right, so basically you're going to go to the folder where you have your file stored. Okay, so this is the phone stand, or you could open it up here on this tab. I'm just going to drag and drop. So you just drop it in, and it automatically picks up an orientation. Okay, careful thing to note here would be obviously the different colors. So Cura is automatically going to load in and have your part in yellow. Okay, don't be alarmed that this is totally dependent on the material that you put in your printer, obviously. So the yellow is basically the top surfaces that you have, and obviously the side surfaces here. And the careful thing to note would be the red. So all these red surfaces that you see here, obviously this yellow part at the bottom here is going to be flat on the bed. So obviously this is the bed surface. And yeah, so the red part is basically where you're going to have some sort of support. So you need some sort of support structure ideally, or you'd see in a bit that a part like this can be printed without supports, but the printer recognizes that these are surfaces that are overhangs, and they overhang in terms of leaning over. They're not perfectly vertical. Okay, so that's just something to note. Now, in terms of you understanding how to put a support in, that's where actually reading the description comes in. So if you look at what the designer said here, he said supports no. So when you think about a support is basically a structure that's like if you needed to print in here, it needs to hold this up as it builds layer by layer. So if you look at preview here, it actually shows you each of the layers. So if you look on the side here, you got 243. So if you move that down, it shows you each layer. So this has 243 layers. If we start from layer 1, it shows you as you go up through the layers what it builds. So if I zoom in there, it's going to show you. So if you start at 1, obviously that's the main. You can notice on the side where the arrow, the cursor is, you see that starts coming out as you build and get higher and higher and higher. So according to the designer of this phone stand, he said that it can be done. These overhangs can be done without support. So just the support material is so if you had a really steep overhang that a printer couldn't do, maybe you'd have a support kind of like here that bridges basically the gap. So this when the printer prints this, it doesn't fall over. but this has been designed so that you don't need supports in there, right? So obviously support uses a lot more material that you eventually end up throwing away, and ideally you don't want to print with support if you don't have to. You can override the setting here and print with support even though you don't need to, but it's always a good idea to read the description of the designer so you have an idea. Okay, so look, you can even automate this process, and you can click play here and it will show you how the extruder moves around, and it will show you this layer by layer how it's actually laid down. Okay, so yeah, that's the G-code, magic of the G-code there, right? So basically the printer is going to do this for 243 layers, and it's just going to go on and on and on from the bottom all the way to the top. Okay, so if we come on the side here in the settings, you've got something called layer height. So if you hover over this, right, it tells you, okay, so layer height is the height of each layer in millimeters. High values produce faster prints in low resolution, low values produce slow prints in high resolution. So obviously the smaller you make this value, the more accurate or the more fine your print is going to be, but obviously it's going to increase your time in terms of how fast you can actually print it. So you need to look at the manufacturer's what you call it, instructions on your printer and what kind of nozzle you have installed. But most 0.4 mil nozzles that you get out of the box, you should be able to go in from 0.1 all the way up to maybe 0.3. I think that's advisable. I think more than 0.3 is not going to be good enough for that nozzle. But obviously there's charts and things that you can make note of and have a look at. Okay, so the purpose of this video is just to show you guys how to do slicing. So if I pick 0.2, this is a good like draft value, just to see what it will look like. And then you go on initial layer height, so that's usually 0.2. So the reason that's at 0.2 is basically to allow that first layer to be on the bed properly. As you guys know, with 3D printing, you want that first layer to adhere really well to the surface. Okay, line width, these things are all automatic, right? I'm not going to change them, but obviously if you hover over it, it tells you exactly what it does, right? I'm not going to explain each function because it's just going to take too long, but the important one here to note is the 0.2, right? Another thing that's important to know here is your shell. So your shell settings in terms of your wall line count. So Cura has a nice setting here which allows you to automatically calculate your wall line count, but obviously you can make that whatever you want, right? So if you look at your wall line count, so the more walls you put, the more perimeter walls you put on your part, obviously the stronger it's going to be. So if you look at this part, these lines on the outside, are your perimeter walls. Obviously if I put in 5 there, I'll show you what that looks like. You can see obviously now there's more. Okay, so obviously it's going to make your part stronger because you've got more walls on the outside, kind of like coloring in a picture. You've got more solid on the outside, and the inside is just mainly filled. Okay, so usually you don't want to go more than 3. Yeah, so wall line count is important here. Then if you look at top layers, okay, bottom layers, you can change those depending on how thick you want the top and bottom layers to be. Okay, enable ironing. So ironing is quite cool. So what ironing does is it will take your nozzle. Remember the nozzle is going to be quite hot, and it will basically not extrude material out of the nozzle. So when you're doing your surface that's going to be ironed, so say the topmost surface, what it will actually do is it will actually pass the hot hot nozzle over the surface, and it will basically blend all of the lines in. You don't see those lines. Okay, so that's a cool feature in Cura. Next you have infill density. So with infill density, this is basically changing the density of the infill or the structure inside. This is the structure that supports the outer perimeter walls and keeps everything together inside. So I've got it quite coarse here. Let's look at something like 10. Let's look at something like 10, and then we can see how it changes. If you look at 10, you can already see, I mean, it's quite coarse there. There's not much infill in. You got a lot of air. Okay, obviously this pattern that I've got here is cubic. You can obviously change them depending on the strength properties you want on your 3D print, but I think cubic is a stock. If you look at 10, I mean, look at the spaces in between here, and if you go with something like let's say 50, then you can see how it changes. Give it a second. So you can see now you've got more of these patterns in, and obviously you've got more plastic, you've got more support, you've got more walls, you've got more of these structures running along the sides. And yeah, obviously the more you go here with infill density, I mean, you can go all the way to 100, which is not recommended because you're basically printing almost solid there then, which is going to take a lot more plastic, and also doesn't always result in a stronger part. Okay, I've seen these structures fracturing and breaking when they printed on 100%, because remember, at the end of the day, this material was not this FDM 3D printing was not intended for creating solid objects. And okay, so you want to have, depending on your application, you want to have something like 50, I'd say 80% maximum. You wouldn't go more than that. All right, then, as I said, you can change this. So let's go put that in so you guys can see. So look at that. You can change it to something like lines. Let's show you what this looks like. So lines would just basically go around like that, go down and up. Then you could go something like concentric. Okay, this obviously now depends on the strength characteristics that you want. Okay, or you could go something like gyroid. Okay, and that's obviously, it's got a zigzag wave to it, but more or less of the time you're going to use cubic subdivision, right? This gives you like a balance, creates a good lattice structure inside. Okay, so then what else can we say here in terms of infill? Line distance, you're not really going to change. Overlap percentage, not really. Okay, so this part's important, right? If your machine doesn't have if your machine settings are not 100% click and drop in terms of here, in terms of Cura recognizing your printer, then I think here you need to pay a bit of attention. And then also when it comes to your material, if your material is if it's not listed here, then you want to basically pay careful attention to this. So if you look at the filament manufacturer or the label on your filament box, they will give you recommended temperatures for printing. So at the moment this is on PLA, which is on 200. This would range 200, 205, 210 depending on the manufacturer, right? Moving on to the bed build plate temperature, this is usually standard at 50, but you obviously can change it. With PLA you don't need any temperature, you can have it on 0, but materials such as like ABS, PET, you do need some sort of heat. All right, so if you look at print speed, okay, so this is important. Now a lot of printers, like even my my Creality machines, you can override this on the fly on the machine itself, but maybe some machines you can't. So you need to pay attention to this: the print speed, infill speed, wall speed. This is the default settings from Cura, but obviously you can change it depending on how fast you want to go, and obviously the recommended speeds and feeds. Infill here would be a feed. in terms of what your machine can do. All right, these settings I usually leave them off. Acceleration control, jerk. Okay, retraction is very important. You must have retraction on. This basically allows your stepper motor that feeds in, okay, that feeds in your PLA. It allows it to go forward and backward. Okay, so you always want to have retraction. Cooling, definitely enable print cooling. Okay, you're going to get more detailed prints with cooling on. In some cases, you won't get good quality in terms of bridging and overhangs. It won't get printed properly if you don't have cooling. Okay, fan speed 100%. You're not going to change that. Okay, so this would be the support section. Okay, so if you click on generate support, it's now going to override the settings, right, and it's going to give you a support. So if you go on preview and you actually move up, okay, it's going to give you the support structure, okay, which you don't really want. Look, you'll have to change the overhang angle. So if you make this like 70 degrees, okay, then obviously it's going to change the characteristics. All right. Obviously here this part doesn't need what you call it, supports, so it's not really going to print them. But yeah, you can see the time hasn't changed as well. Okay, so we put the support off and move down. Bull plate adhesion type, that's usually skirt, but you can choose between brim and raft. So brim is basically going to be at the base of the part. This helps it to stick nicely. You can see it's joined, but this is just a headache for cleaning the end, so I usually just use skirt. Moving on. Okay, so you're not going to really do anything here in terms of dual extrusion, visual modes, and experimental. Those are just usually just closed. Okay, so once you're happy with all of these settings and you're happy with your part, you go, you can obviously note the time here, 4 hours 5 minutes. Okay, it's quite a bit of time for something so small and simple, but you know, it's recommended settings and you're going to get a good finish here. It's going to be strong. So, and then also it tells you the amount of plastic you're going to use, and in terms of the meterage, in terms of the roll. You click on save to file, and then obviously you can save this anywhere. Now just note that it's being saved as, obviously it's going to create a name automatically. This would be the name of your machine. So in my case, when I save G-code, I save it for 2 different machines, just to make sure that the size obviously correlates. Okay, and then obviously you're going to see it's got a .g-code. So that's the important part here. You're going to go from STL to G-code file, and this obviously gives you your machine instructions so that your 3D printer can actually execute the XYZ plot points in space, and it can print it layer by layer. Okay, so once you're happy with the name, you're going to click on save, and then obviously Cura is going to tell you where it's been saved and allow you to open the folder. So at this stage, you're obviously going to go in and save this G-code onto your micro SD card or transfer it onto your printer. And obviously you're going to go into your printer settings and you're going to select this printer and obviously print it. Yeah, so I will be showing you guys how to actually execute the print on a Creality machine, on one of my machines. That's a soon to come video, and I hope you guys enjoyed this video. I will be making another one on something more complex, another bigger part. Okay, but yeah, just last minute thing. In terms of actually changing things here, you can, like if you wanted to make this part, if you wanted to move this part around on the bed, also if you wanted to make more than one, so you can just right click on this and click on multiply. So I want to make another one. Okay, and yeah, I mean, You can make as many as you can fit on your bed here. So if I wanted to make 4, I think 4 can fit on here. Let's see. Or easy way, just delete and click on multiply and click on 3. Okay, so I think we can fit 3 in here. Okay, so obviously the one with the zebra lines on the outside is going to be that it doesn't fit. So obviously you can fit 3 here, right? And obviously it's going to take your time. It's going to tell you 16 hours, 39 minutes. Okay, so that's one thing you can do. Another setting here is obviously scaling. So if you want to make this part smaller, you can. So let's reduce it by 50%. All right, for say some odd reason you want to make something smaller, you can in here. You don't need to actually go in on SolidWorks or Inventor or something and actually change it. You can do it here if you're just scaling it. And then obviously you got a setting for uniform scaling here. So let's say you wanted to not scale it uniformly. You wanted it to be maybe longer in one direction, something like that. So you can make this 100% and keep the others. You see it just widens it out. Let's delete these. You can see clearly. You can see you can scale it as much as you want. And then when you're done, you can just reset. Just remember to take this back. You can rotate it as well. So for some reason, if you want to rotate things around, you can. Okay, say you wanted to print it that way. Okay, I will be doing another video on placement and optimal placement and that sort of thing, because that's another topic in terms of understanding how to place things properly for the correct strength, which is quite interesting. Yeah, so you can rotate that. Obviously here you can mirror things and all the rest of it, right? Okay, so we'll stop there on this video, and hope you guys enjoyed it, and you can actually go in now and just make G-code of things and get to 3D printing. Cool.